Hello, hola. My name is Silvio Nelly Resto. I'll be doing the part one proposal. Title of this paper will be implementing the engineering design process for cross learning in bilingual math and geometry. A professional development proposal, introduction and areas. STEM teachers must implement the engineering design process in a build problem solving, critical thinking, and collaborating skills critical for STEM success. For the bilingual math, geometry in the state of Illinois, students is also enhanced large development through collaborating decisions and technical vocabulary by adapting these approaches. The teacher supports the diverse learners to technical complex challenge and communicating efficiency, preparing them for the STEM career. More 2014. Now we'll be talking about the learning objective. Students will apply geometry, principled engineering, practical to design and evaluate model, which is using the perceived mathematical language in both English and the native language. Researchers showed that concepts which are adjective in bilingual settings enhance cognitive and linguistic skills, improving outcome, Echevarria 2017, analyzing of the engineering design process, students connect math, language, and a real world application. Thank you.
The engineering design process is something that all content teachers can use to integrate STEM as it emphasizes open ended problem solving. Teachers can use this process during cross curricular instruction. Cross curricular instruction that combines math and science while giving open ended problems for students to solve implements STEM into the classroom, while giving students the opportunity to use the engineering design process. For example, when learning about density, students learn the science and math behind an object's ability to float. Students could be challenged to build a boat out of tinfoil using the equation for density to try to make a boat that holds the most pennies without sinking. This uses cross-curricular instruction and also implements STEM and hands-on learning experience into the classroom.
Professional learning communities, or PLCs, play an important role in supporting STEM teachers and implementing different strategies for English language learners in geometry. Regular meetings, resource sharing, and collaborative discussions are essential for achieving this goal. A central place to share documents like Google Drive or Microsoft Teams can be used to share lesson plans, instructional materials, um, and you can also give peer feedback and lesson study. Collaborative planning will involve co-planning sessions and ensuring that differentiation strategies are integrated into instructional plans. Continuous professional development will include workshops and training, expert-led sessions, mentorship, and coaching sessions. Monitoring and evaluating will involve data-driven decisions, student performance data, feedback surveys, self-assessments, and PLC reflections. By maintaining a structured and collaborative approach, the PLC can effectively support STEM teachers in implementing differentiation strategies to ELL students, ultimately enhancing the learning experience for all students.
I will incorporate the principles of engineering design into my future teaching practice in the area of computer programming and business. I'll provide STEM learning activities and strategies that will put a focus on cross-curriculum and real-world learning. This will develop skills that will make an impact on students' future lives. Including the steps of the engineering design process will be an integral part of the culture in my classroom throughout the school year. I will do this by teaching the steps of the process, modeling the process, and then giving feedback to the students as they practice the steps themselves. For example, I could assign my business students an upcycling project. Students would go through the steps of the engineering process, including coming up with a problem that connects to their own lives, such as I struggle with organization and could use a product to keep me organized. I would give feedback to the students so they will know their strengths and how they can improve. By utilizing the engineering design process in my classroom, my students will be able to develop essential skills such as problem solving, thinking critically, and collaborating with others for improving their future lives as adults.
By using the engineering design process, students engage in problem solving, collaboration, and critical thinking, through hands-on activities that apply theoretical knowledge to real-world scenarios. For bilingual students, this approach enhances both language skills and STEM comprehension. I hope you saw how aligning the engineering design process with math and science standards, such as designing geometric structures or solving real-world engineering challenges, fosters a deeper understanding of geometry, scientific inquiry, and technical vocabulary. This is a process that is perfectly suited for cross-disciplinary STEM instruction, and I hope you guys learned how to implement it well. Thank you.